All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. In this particular session, we will be discussing that is collisions. Okay, collision is one of the most important topics when it comes to your NEET physics. And some people study it after work, power, energy. Some people study it after Newton's laws of motion, and some people study it after center of mass. It depends upon the teacher. Now, when it comes to the collegians, I would say 1 to 2 questions you can expect from this particular portion, and it is very easy. I'll be starting from the scratch. Doesn't matter if you don't know the basics, but I am 100% sure you would be able to understand each and every single thing. That is my guarantee. Okay. So make sure you smash the like button and you share it with your friends also, because liking the session means marking the attendance. You guys are supposed to smash the like button. Let's dive into the session. Okay. So, my dear NEET aspirants, we have this collegians over here. Okay. What does collegian actually mean? What does collegian actually mean? Listen carefully, everybody out there. I'll make you understand the collegians. What does collegian actually mean? See, guys, let's suppose you have a mass over here that is m1. Okay. It is moving with certain speed. Let's suppose it is u1. This mass m1 is moving with certain speed, that is u1. And there is over here mass m2. It is moving with speed, that is u2. Okay. M1 is moving with u1 and m2 is moving with u. Now they are colliding with each other. Now they are colliding with each other. So these two masses are actually colliding with each other. Okay. So basically, this m1 and m2 collided with each other. This is m1 and this is m2. After the collision, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. Listen to me very carefully. I would say after the collision, this is mass m1. It is moving with speed, let's suppose v1. And this mass m2, it started moving with speed, let's suppose v2. Okay, this is after the collision. After the collision, they are moving with mass v1 and v2. So, my dear NEET aspirants, this is what we call the collision. That's it. So, when two masses collide with each other, okay, then after the collision, they started moving with different velocity. That is v1 and v2. So, in this particular case, my dear NEET aspirants, we say m2 is applying the force on m1 is applying the force on m2, that is f21, force on second due to first. Similarly, this m2 is applying the force on m1, that is f12, that is force on 1 due to second. These are the internal forces. The first point that I want to tell you in this particular case, we say external force net in this case is 0. There is no external force acting in this particular case. I want you to understand this. Okay. Sir, this F21 and F12, these are the internal forces. Okay. If net external force on the body is 0, we say momentum is conserved. We say initial momentum is equal to final momentum. So can I say in this particular case also momentum will remain conserved? Absolutely, sir. Now, what is the initial momentum? Initial momentum of this entire system. That is momentum of these two masses. What will you say? You'll say, sir, momentum initially is m1u1 plus, I would say, m2u2. This is the momentum initially. Okay. Then final momentum is going to be, that is m1v1 plus, I would say, m2v2. This is the final momentum. Because after the collision, moment velocity is v1 and v2. So this is what we call conservation of momentum. So what I can say, momentum is conserved in all type of collisions, all types of collisions, all types of collisions. Whether it is elastic, inelastic, okay, whatever it may be, momentum is conserved in all types of collisions. I believe this is crystal and clear to each and every single student. Yes. So this is what we have studied till now. That is When it comes to the collisions, we say if a mass is moving with m1 and mass m1 and m2 is moving with u1 and u2, after the collision, velocity is v1 and v2. We say momentum of the system in this particular case is conserved. Now take a look. I have mentioned the definition over here. Collisions. It is the interaction between two or more than two objects. What is collisions? Interaction between two or more than two objects in which net external force is zero. This we have discussed recently, in which net external force is zero. Okay. So momentum of the system always remain conserved. So momentum of the system always remains conserved. So this is before the collision. This is after the collision. M1 U1, M2 U2. Okay. 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 Now, my dear NEET aspirants, in this particular case, just a second, I need to add some pages over here. Paste, paste, and paste. Take a look, guys. So, what did I tell you? Momentum of the system always remain conserved. Momentum of the system always remain conserved. Okay. See, guys, I'll write over here M1 U1 plus I would say M2 U2. Better is to write in the vector form because sometimes velocity may be given in two dimensions. In that case, you'll be using the vector form. It will be equals to M1 V1 plus I would say M2 V2. As simple as that. As simple as that. Absolutely, sir. Now, my dear NEET aspirants, one more important thing I just want to tell you. One more important thing I just want to tell you. Sir, momentum of the system remains conserved. But if I say momentum of individual masses, momentum of individual masses, individual masses is not conserved. Momentum of the individual masses is not conserved. Like what I'm trying to say is that, what is the momentum of this individual mass over here? M1 U1 before the collision. What is the momentum of the same mass after the collision? M1 V1. Is it same or different? Sir, it is different. For the entire system, I would say momentum remains the same. For the entire system, momentum remains the same. Okay. Momentum after the collision, momentum before the collision. This one, M1 U1, like this. Individual masses do not conserve the momentum over here. Then, my dear NEET aspirants, next point I just want to mention over here. What is that? Listen carefully. Listen carefully. If I say what is the relative velocity of approach? Relative velocity of approach. What is the relative velocity of approach? Sir, what does that mean? Relative velocity of approach is nothing but, guys. What is the velocity of approach? Velocity of approach means with what velocity they are approaching towards each other so that they can collide. So relative velocity of approach is simply going to be u1 minus u2. Okay. Means relative velocity is what? Velocity of first minus velocity of second. So relative velocity of approach will be, you will be simply saying that it is u1 minus u2. This is the relative velocity of approach. And then, my dear NEET aspirants, if I ask you, if I say, what is the relative velocity of separation? With what velocity they are separating? Sir, they are separating with velocity v1 and v2. So I'll just write over here, relative velocity of separation. It is simply, that is v1 minus v2. v1 minus v2. Or you can write v2. Better is to write v2 minus v1. That is correct. v2 minus v1. v2 minus v1. Okay. Okay. Now, if you divide the two equations, relative velocity of separation by relative velocity of approach, that is v2 minus v1 upon u1 minus u2. This is what we call E. E means coefficient of restitution. This E is actually coefficient of restitution. Coefficient of restitution. So, my dear NEET aspirants, till now you studied what is the relative velocity of approach, with what velocity they are approaching towards each other, with what velocity they are separating from each other, v2 minus v1. Okay, like if I say this velocity is 10, this is 5. So with see, if I say this v2 is 10, this is 5. With what velocity they are separating? 10 minus 5, that is 5. So 5 is relative velocity of separation. Okay. Now, guys, let's move on to the types of collision. Let's move on to the types of collision. The first type of collision is called elastic collision. Listen to this very, very, very carefully. First type is called elastic collision. We say it is that collision after which two objects regain its shape, size, etc. Okay, like. Take a look, my dear NEET aspirants. This is mass M1, which is moving with velocity U1. This mass M2, it is moving with velocity U2. When they collide with each other, some deformation take place. Some deformation takes place. So after the collision, we say both are attaining the same shape and size. Okay, that is called elastic collision. That is called elastic collision. Even I would say one more important point over here. It also regains its kinetic energy, which was converted to potential energy during the collision. Whatever is the kinetic energy of the system initially, let's suppose 10 joule, 5 joules, that is 15 total. So finally, after the collision, both will have the 15 joule of kinetic energy. They regain their kinetic energy. They regain their shape, size. That is what we call elastic collision. And now see. Sir, for elastic collision, coefficient of restitution is 1. Now you got the feel of coefficient of restitution. Coefficient of restitution basically tells you what type of collision is there. If E is 1, means elastic. Okay. So it is decided by coefficient of restitution what type of collision is basically there. What type of collision is taking place. Okay. Absolutely. Now, certain things we need to understand in this one. Take a look, guys. What is that? What is the first thing you want to understand over here? See, guys. See. The first thing I would want you guys to understand over here is, see, guys. If coefficient of restitution is 1, what are you going to write? You'll say, sir, V2 minus V1 divided by U1 minus U2. Velocity of separation divided by velocity of approach. It is equal to E, so it will be equal to 1. So don't you think that V2 minus V1 will be equals to U1 minus U2? Yes. What does that mean? That means velocity of separation will be equals to velocity of approach. So in case of elastic collision, with what velocity they are approaching, same will be the velocity of separation with what velocity they are separating. This is the important point. And one more important thing in this particular case, my dear NEET aspirants, is what is that? That is kinetic energy before the collision. Kinetic energy before collision. Don't you think that it will be kinetic energy after collision? It will be kinetic energy after collision. 100%, sir. Absolutely, sir. Okay. 100%, sir. Just a second. Okay. Kinetic energy before collision, kinetic energy after collision. Okay. And my dear NEET aspirants, we say here kinetic energy remains conserved. Okay. And one more important thing, velocity of M1 and M2 after the collision. So you need to basically find the velocity of M1 and M2 after the collision. So after the collision, velocity of first mass directly, I'll not be deriving it over here. Velocity of first mass, it is going to be, that is m1 minus m2 into u1, then divided by m1 plus m2, m1 plus m2, plus 2 times of m2 u2 upon, I would say, m1 plus m2. Guys, this is very important. You guys need to understand this in this particular case. In this particular case, this is very important. Okay. So, my dear NEET aspirants, this is the velocity of first mass after the collision. First mass is this one. So after the collision, it has got velocity v1. This is the value of velocity v1. Now let's write the velocity of v2. Let's write the velocity v2. So v2 will come out to be, okay, that is going to be m2 minus m1 into, I would say, u2 upon, that is m1 plus m2. Then we say plus 2 times of m1 u1 upon m1 plus m2. This is going to be the velocity. This is going to be the velocity of second mass after the collision. Velocity of second mass after the collision. Please tell me, okay, if I hope this is clear. I hope this is clear. Okay, this is the velocity of first and second mass. Now, my dear NEET aspirants, let's move on to the inelastic collision. Let's move on to the inelastic collision. Take a look. Take a look. Let's move on to the inelastic collision. Sir, what does inelastic collision actually mean? What does inelastic collision actually mean? We say it is that collision in which the objects does not regain its kinetic energy. In which the objects does not regain its kinetic energy. Okay? Okay. Even one more important thing. After the deformation, the masses do not regain its original shape and size. What was elastic collision, my dear NEET aspirants? After the collision, two objects were regaining its shape, size, everything, even kinetic energy also. But in this case, object does not regain its shape, its size, and object does not regain its kinetic energy also. Okay. Okay. Like you can clearly see this mass m1 u1, m2 u2. When they're basically colliding with each other, okay, some deformation takes place. So after the deformation, you see this is deformed. After deformation, this is deformed. So both the objects are deformed. They have not regained their shape and size. So kinetic energy also does not regain. And here we say coefficient of restitution is, this E is greater than 0, less than 1. It is between 0 and 1. So if coefficient of restitution is between 0 and 1, you can say the collision is going to be inelastic. You can say the collision is going to be inelastic. Now, my dear NEET aspirants, take a look. Take a look. So E decides basically the elasticity. If E is less than 1, then means body does not regain its shape and size. So E basically defines the elasticity. If E is less than 1, body does not regain its shape size. If E is equal to 1, body regains its shape and size. So I'll just write over here inelastic collision. Inelastic collision. I can say M1 U1 will be equals to M2 U2. Okay, wait. M1 plus M1 U1 plus M2 U2 will be equals to M1 V1 plus I would say M2 V2. Okay, absolutely, sir. So momentum of the system remains conserved in this particular case also. Momentum of the system remains conserved in this particular case also. Is that clear? Yes. So momentum remains conserved in all types of collisions, whether it is elastic, whether it is inelastic, doesn't matter. But here, coefficient of restitution is between 0 and 1. Let's suppose in this particular case, we say if E is 0.5 and E defines the elasticity. If E is less than 1, object does not regain its shape. If E is equal to 1, object regains the shape. So we can say V2 minus V1 divided by U1 minus U2 is equal to E. Instead of E, I can write 0.5. 0.5 means 1 by 2. Now take it over here. Or we can say V2 minus V1 will be equals to 1 by 2 of U1 minus U2. So can I not say in this particular case, what I can say, this is velocity of separation. This is velocity of separation. This is velocity of separation. It is equal to 1 by 2 of velocity of approach. You can clearly see in this particular case, velocity of separation is less than velocity of approach. Velocity of approach. So you can clearly see in this particular case, velocity of separation is less than velocity of approach. That's what I was saying. Velocity is decreased in this particular case. Okay. Velocity is decreased in this particular case. So it is obviously the magnitude. So if magnitude of velocity decreases, kinetic energy decreases. So that's why. But in case of elastic collision, we say whatever was velocity of separation, same was velocity of approach. So I can say, what I can say in this particular cases, that is kinetic energy finally will be less than kinetic energy initially. So I can say kinetic energy is lost in compression or deformation. So kinetic energy is lost in compression or deformation. That is what I can say in this particular case. Okay. And velocities of two objects after the collision. I would write velocity of M1 and M2 after the collision. Velocity of M1 and M2 after the collision. So when it comes to velocity of M1 and M2 after the collision, and which collision we are talking about? Inelastic collision. That is going to be V1. So this V1 will be M1 minus E times of M2 into U1 upon M1 plus M2. Then plus E plus 1 into M2 U2 upon M1 plus M2. This is going to be the velocity of first mass after the collision. This is going to be the velocity of first mass after the collision. Then if I say V2, V2 is M2 minus E times of M1 into U2 upon M1 plus M2 plus E plus 1 M1 U1 divided by M1 plus M. I'll be telling you the trick also later on to remember this. Okay. This was basically in inelastic collision. I have told you all the details of inelastic collision. We say kinetic energy is not conserved, but momentum is conserved in this particular case. And in case of elastic collision, we say kinetic energy is conserved, momentum is conserved. Okay. Kinetic energy before collision is equal to kinetic energy after collision. Let's talk about perfectly inelastic collision. What type of collision is this? It is that collision in which body sticks to each other after the collision. Like one object, this is M1 and this is M2. Basically, when they collide with each other, when collision takes place, after the collision, they stick to each other and they start moving collectively. Okay, so this is after the collision. So if they are moving collectively after the collision, so whatever is the speed of first, same will be the speed of second, and let's call that v. Okay. Now, my dear NEET aspirants, what I can say in this particular case, listen carefully. What I can say in this particular case, that is, we say here, coefficient of restitution is 0. So this coefficient of restitution defines which collision is taking place. If it is 1, elastic. If it is less than 1, inelastic. If it is exactly 0, it is perfectly inelastic. So I can say V2 minus V1 divided by U1 minus U2. U1 minus U2. It will be equals to E, and E is 0. So multiply this over here. So I can say V2 minus V1 will be equals to 0. So I can say V2 will be equals to V1. V2 will be equals to V1. This is the velocity of second object is equal to velocity of first object is equal to V. That's what I was saying. I have proven it also. Okay. And if you ask me, sir, what about kinetic energy? I can say kinetic energy is not conserved. Whatever is kinetic energy initially, finally kinetic energy will not be the same. Okay. Then momentum is conserved. Momentum is conserved. Momentum is conserved. Because I would say net external force is equal to 0. Net external force is equal to 0. Because net external force is equal to 0. Now, my dear NEET aspirants, what I can say in this particular case, we say M1 U1 plus M2 U2 will be equals to. When it comes to the momentum, what is the momentum initially? M1 U1 plus M2 U2. It will be equals to final momentum is M1 plus M2 into V. Because finally the two masses are moving collectively. That's why M1 plus M2 into V. This is the final momentum. This is the final momentum. Okay. And if somebody asks you what is this final velocity from here, you can say it is M1 U1 plus M2 U2 upon I would say M1 plus M2. I would say M1 plus M2. This is the final velocity that I can say in this particular case. This is the final velocity of the two masses in this particular case. Okay. Yes. Now, guys, listen carefully. I told you perfectly inelastic. I told you inelastic, and I told you elastic. These two expressions will be considering as the general expressions. Listen to me very carefully when it comes to the velocity. Okay. Consider these two as general expressions. Consider these as general expressions. Okay. Yes. What I'm trying to say is that we say this is the velocity V1, which is the velocity of first mass after the collision. Velocity V2, that is the velocity of second mass after the collision. We say for elastic, you will be saying value of E is 1. Okay. Yes. And for perfectly inelastic, you can say value of E is 0. Put the value of E is equal to 1 over here. You'll get M1 minus M2 into U1 upon M1 plus M2. Then E is 1. 1 plus 1 is 2 times of M2 U2 upon M1 plus M2. Now let's check. Let's check. m1 minus m2, okay, in this particular case, into u1 upon m1 plus m2 plus, I would say, 2 times of m2 u2 upon m1 plus m2 upon m1 plus m2. I believe this is crystal clear to each and every single student. I believe this is crystal clear to each and every single student. Okay, okay, yes. And if you put the value of E is equal to 0, okay, put E is equal to 0, in this particular case, this term will be 0. So this will be m1 into u1 upon m1 plus m2 over here. Okay, okay. And this will be 0 plus 1 is 1, m2 u2 upon m1 plus m2. Okay. So basically in this particular case, you can simply do one thing. You can simply do one thing. See guys, see guys. For, see. For perfectly inelastic, what you guys can do in this particular case is, see, this is inelastic collision expression. So for inelastic collision expression, you can say m1 minus m2 and value of E you need to put over here as 1. Okay. Okay. Then my dear NEET aspirants, you'll get the value of V1 and value of V2. Okay. And for perfectly inelastic, what is the value of E? E will be in that particular case, that is 0. Okay. E will be in that case 0. So when E is going to be 0, so you are going to get this expression. You are going to get this expression. And you can find this expression using conservation of momentum also. Conservation of momentum also. I believe this is crystal and clear. Now we need to basically understand what? We need to understand loss in kinetic energy also. We need to understand loss in kinetic energy also. Okay. Yes. Loss in kinetic energy in perfectly inelastic, loss in kinetic energy in what? In inelastic, and loss in kinetic energy in perfectly inelastic. This. And what about loss in kinetic energy in elastic? In elastic, loss in kinetic energy is actually 0. Okay. Loss in kinetic energy is actually 0. Okay. Yes. Because whatever is the kinetic energy initially, same is the kinetic energy finally. Okay. Yes. So my dear NEET aspirants, this is perfectly inelastic. This is inelastic, and this is going to be perfectly inelastic. Now, I hope you got these two expressions clearly. So you will be considering this as general expression. And when you put A is equal to 1, you'll get expression of elastic. When you put E is equal to 0, you'll get expression of, I would say, inelastic, perfectly inelastic. Okay. Yes. Now, my dear NEET aspirants, let's talk about the loss in kinetic energy over here. Loss in kinetic energy over here. When it comes to the loss in kinetic energy, we say kinetic energy initially is equal to kinetic energy finally. So if kinetic energy initially is equal to the kinetic energy finally, then we say in that particular case, my dear NEET aspirants, we say loss is kinetic energy, loss is 0. Loss will be only if you have lost some kinetic energy. So if it is same, so kinetic energy loss is going to be 0. In case of inelastic collision, what is going to be the loss in kinetic energy? Delta Ke loss. I would want you guys to directly remember this. So it is going to be 1 by 2, that is m1 m2 upon m1 plus m2, then u relative square 1 minus E square. So where does this expression come from? There is a derivation for this. We are not going to do that because that is just the wastage of time. You directly remember this. You directly remember this. And in this particular case, I would say U relative is U1 minus U2. U relative, what is the relative velocity? Initial relative velocity, that is U1 minus U2. Okay, that is U1 minus U2, as simple as that. As simple as that. As simple as that. Okay, just a second, guys. Okay, yes, absolutely. Okay, yes. Now, guys, let's move on to this one, perfectly inelastic. What about loss in perfectly inelastic? You can say, sir, delta ke loss. This is simply going to be, that is 1 by 2. Then I would say m1 m2 upon I would say m1 plus m2. Then you have a u relative square. U relative square. Okay. I believe this is crystal clear to each and every single student also. Okay. This is perfectly inelastic. This is the loss in kinetic energy in inelastic, in elastic, in perfectly inelastic. You have to remember these expressions directly. Let's move on to this particular question over here. Two masses 4 kg and 8 kg collide with each other, and collision is perfectly inelastic. Collision is perfectly inelastic. Find the velocities of the masses after the collision. If the collision is perfectly inelastic, what is the velocity of the two masses after the collision? That is this. M1 M2 plus M2 U2. Sorry, M1 U1 plus M2 U2 upon M1 plus M2. So what I can write over here in this particular case, that is, and the diagram is given something like this, my dear NEET aspirants. Listen to me very carefully. When the two masses basically collide, okay, perfectly find the velocity. Okay, the diagram is given over here. The diagram is given over here. See, this moving with 2, this moving with 4. Now, guys, in this particular case, if the collision is perfectly inelastic, we say the two masses will stick to each other. This is m1, this is m2, and they will move with a velocity u2. Sorry, v. And this will be equals to v1, and this will be equals to v2. And if you ask me what is the value of this velocity, value of this velocity is going to be m1 u1 plus m2 u2 upon m1 plus m2. And my dear NEET aspirants, m1, what is the value of first mass? Okay, it is given over here. 4 kg, 8 kg. So what I can write over here, this is 4, and velocity of u1 is 8 into 8. Then minus. Why am I writing minus? Because this velocity is negative velocity because it is in the left direction. So its mass is 8 into 4. Velocity is 4, mass is 8, divided by 8 plus 4. So plus 8 into 4 minus 8 into 4, it is 0. So the bodies will come to rest if the two velocities hit to each other. So the body is going to come to rest afterwards. That is for sure. That is for sure. Body will come to rest. I believe this is crystal clear to each and every single student. Let's take a look at this question. A ball of mass m moving with a velocity v collides head on head with the second ball of mass m at rest. Okay. Take a look at this question, guys. Take a look at this particular question. See, guys. See, guys. So a ball of mass m moving with a velocity v collides head on head with another second ball of mass m at rest. There are two balls. This is first one. Its mass is m. And it is moving with velocity v. So u1 is given as v. There is another mass which is at rest. So its u2 is 0. Okay. Now it says if the coefficient of restitution E is E, then the velocity of the first ball after the collision is v1. Okay, and velocity of second ball after the collision is v2. Then v1 and v2 will be. So you have to find the velocity of the two masses after the collision, and coefficient of restitution is given as E. Coefficient of restitution is given as E. What does that mean? What does that mean, my dear NEET aspirants? What does that mean? That means it is inelastic collision. If it is given as 1, you'll be considering elastic. If it is given as less than 1, you'll be considering perfectly inelastic. Sorry, if it is given as 0, it's perfectly inelastic. If it is generalized, that is E, it is inelastic. So I'll be saying consider inelastic. Consider inelastic. Okay. So my dear NEET aspirants, what I can say over here in this particular case. So this is M1. It is moving with a velocity, I would say U1, sorry, V1. And this is M2. It will be moving with velocity V2. We have to find the value of V1 and V2. In case of inelastic, what I can write, V1 will be equals to, that is M1 minus E times of M2 into U1 upon M1 plus M2, then plus E plus 1 M2 U2 upon M1 M2, M1 plus M2 plus M2. Okay. Now, my dear NEET aspirants, what I can say in this particular case, what is the value of M1 and M2? That is M. So this is M minus E times of M upon M plus M is 2M. Because both are given the same masses. Then this term is going to be 0. This term is going to be 0. This. Why? Because what is the value of U2? 0. So here U2 is mentioned. So 0 multiplied by entire thing is 0. So this is the velocity of first mass. Even you can take this M, you can cancel this M also. So what remains? 1 minus E divided by 2 is the velocity. Okay. Okay. And this U1 is U1. And what is the value of U1? That is V. So instead of U, I'll write V. And similarly, if I say what is the value of velocity V2? What is the formula for V2? That is M2 minus E times of M1 into V2. Okay. Sorry. Into U2 divided by into U2. Yes. Divided by M1 plus M2. Then plus E plus 1 into M1 U1 divided by M1 plus M2. Now in this particular case, this term is going to be 0. In this particular case, this term is going to be 0. Why? Because U2 is multiplied with the first term. Because U2 is 0 now. So V2 will be E plus 1. Okay. Then M1 U1. M1 U1. M1 is M, U1 is V, divided by M1 plus M2, that is 2M. M and M will be cancelled, so V2 will be E plus 1 into V divided by 2. This is the value of V1, and this is the value of V1, and that is the value of V2. I believe this question is also clear. I believe this question is also clear. Okay. Okay. Now, guys, let's move on to the next question. Let's move on to the next question. Next question is this one. A ball of mass m moving with a velocity u. There is a ball. It has mass m. And it is moving with a velocity u. Suddenly, it breaks into two parts of the ratio 2 is to 3. It breaks into two parts of ratio 2 is to 3. So this mass, it is moving with velocity u. Explosion takes place. It breaks into the two parts. 2 is to 3. 2 is to 3 means 2x and 3x. It is not 2 and 3. Keep that thing in your mind. When ratio is given as 4 is to 5, it means 4x is to 5x. Okay. If the smaller mass comes to rest, if this comes to rest, okay. If this mass comes to rest, so velocity is 0 after the explosion. Then the velocity of other mass will be, okay, velocity of other mass will be. Now, guys, in this particular case, what I can say, you have to tell me what is the velocity of the second mass. What is the velocity of the second mass? Now, guys, since this is the case of explosion, in case of explosion, I have told you one thing, that momentum remains conserved. Momentum remains conserved. So can I just write over here? We say here, E is conserved. Absolutely, sir. Without a shadow of doubt, momentum is conserved. Now, momentum, if in this particular case is conserved, so means whatever is initial momentum will be final momentum. Initial momentum is equal to final momentum. What is initial momentum? That is mass into velocity. That is, what is the mass here? M. What is the velocity? U. So I can say that is M into U will be equals to. What is the final momentum? Sir, momentum of this is 0. Why? Because its velocity is 0. So momentum of this will be, that is, mass is 3x into V2. Into V2. Okay. Okay. Now, what can you write the value of this mass? What can you write the value of this mass? So that is 2x plus 3x, because these two are the fragments of this mass only, na? So I can say that is 5x into u will be equals to 3x into v2. This and this will be cancelled. So v2 will be equals to 5 divided by 3u. I believe this is also crystal and clear. I believe this is also crystal and clear. Okay, let's move on to the next question. Take a look, guys. Take a look, guys. The question is a ball of mass 4 kg moving on a smooth horizontal surface makes an elastic collision with another ball, makes an elastic collision with another ball of mass m at rest. If after the collision first ball moves with 1/4 of its velocity, then the mass of the second ball is okay. Mass of the second ball is. See, guys, what does the question say in this particular case? What does the question say in this particular case? It says that a ball of mass 4 kg. You have a 4 kg mass, 4 kg ball, okay, and it is moving with a speed, let's suppose u, and there is another mass m which is at rest, and its initial velocity u2 is 0, and they make the collision. After the collision, it says this 4 kg, it started moving with 1/4 of its velocity, that is u by 4. So v1 is u by 4. And what is the mass of second ball? This m you guys are supposed to calculate. Okay. Now, my dear NEET aspirants, tell me one thing. From this, if I ask you, could you please tell me what is the velocity of the first ball? We say as, and this collision is elastic collision. So in case of elastic collision, in case of elastic collision, what is the value of V1? Sir, we have studied V1 is M1 minus M2 into U1 upon M1 plus M2. Then plus 2 times of M2 U2 upon M1 plus M2. Now, my dear NEET aspirants, what I can say V1 will be equals to. Second ball is at rest. So this term will be 0 because U2 is multiplied to this term. Okay. Now, what is the value of V1? V1 we can write over here. V1 we can write over here. That is U by 4. V1 we can write U by 4. Is equal to mass of first is 4 minus mass of second is M. Absolutely, sir. Into U1. U1 is again U by 4. Sorry. U1 is U. U1 is U. U1 is U. V1 is U by 4. Okay. Divided by M1 plus M2. That is 4 plus M. Now take it over here. This will be 4U plus MU will be equals to 4 into 4 is 16 minus 4M. Wait. So this is 4. Multiply this 4 over here. So this will be 4 minus M into, I would say, U. So you can cancel this U. Now, why am I complicating the things over here? So directly this and this will be cancelled. So this will be 4 plus M will be equals to 4 into 4 is 16 minus, I would say, 4M. So take it over here, take it over there. So this will be 4M plus M will be equals to 16 minus 4. So 5M is equal to 16 minus 4 is 12. Okay. So M will be equals to 12 divided by 5. That is 2.4 kg. I believe this is clear, Crystal. Okay. Let's take a look at this question. The question says a bullet weighing 10 grams. There is a bullet that weighs 10 grams. Okay. Yes, sir. And moving with speed, velocity 300 meter per second. And it is moving with a velocity of 300 meter per second. Just a second, guys. Let me reset this. Okay. Now, guys, let's take a look at this particular question. A bullet weighing, I would say, 10 grams, moving with a speed of 300 meter per second, strikes a 5 kg block of ice. There is a bullet, 10 grams, its velocity is 300 meter per second. It strikes an ice block, okay, and drop dead. Drop dead means it is moving inside. The ice block is kept on a smooth horizontal surface. It is kept on a smooth horizontal surface, means coefficient of friction is 0. The speed of the block after the collision is. So basically, if the coefficient of friction is 0, so no friction is going to hold the block. So when this is going to go inside the block starts moving. So we are supposed to find out with what velocity block is going to move in this particular case. We are supposed to find out with what velocity block is going to move in this particular case. Okay. Yes, sir. Absolutely. Now, my dear NEET aspirants, what I want you to understand in this particular case is something very different. What is that? We say, what type of collision is this? That when see, consider this as mass m1, consider this as mass m2. When the two strikes, they start moving together. This is completely perfectly inelastic. Okay. We say perfectly inelastic collision. Perfectly inelastic collision. Now, what is the velocity of in case of perfectly inelastic collision? That is v, even if this will be v1 and this will be v2. For both velocity of, I would say, block, ice block, as well as velocity of bullet. So it is going to be m1 u1 plus m2 u2, then upon m1 plus m2. Okay. Then is equal to, I would say 10 divided by 1000. M1, I am writing 10 divided by 1000. Why? Because what is the mass of the first bullet? What is the mass of the bullet? 10 grams. 10 grams into kg is 10 by 1000. Into U1 is 300. And U2 is 0 because the block was at rest. So initial velocity of the block is 0. Into U1 is 300 plus M2 U2 is 0 because M2 has mass. U2 is 0. So since this term will become 0. Divided by M1 plus M2. So 10 divided by 1000 plus what is the block of mass of the block? 5 kgs. So it is 5 kgs plus 5. What can you cancel over here? So 0, 0, 0, 0. This 0, this 0. So 3. 3 in the numerator divided by 0, 0. 5. Okay, so this will be how much in this particular case? So this is 3. Okay, so this will be 1 plus 1 divided by 10 plus 5. This will be 3 upon. That is 50 plus 1 is 51 divided by 10. 30 by 51. 30 divided by 51. That is V. Okay. 10 gram M1 plus M2. This is 5 kg. So 10 grams. Did I make any mistake? So M1 U1 plus M2 U2. U2 M1 plus M2. So this is 10 divided by 1000. Plus I would say 5 kgs. 0, 0. Sorry, this 0 and this 0 will cancel out. That is 100. Wait. What did I do? What did I do? What did I do? What did I do? So what remains here? In the numerator, it is 3 divided by 1 upon. Because this is the numerator, na? Upon. So this is 1 divided by 100 plus 5. So this is 3 divided by 1 upon. This is 500 plus 1. 501 divided by 100. So you can write it like this. 3 by 1 into 100 divided by 501. 300 divided by 501. Okay. 300 divided by 501. Okay. This is coming out to be the velocity. I hope this is crystal and clear. Okay. You can approximately say 3 by 5. Now, guys, let's move on to the question. Elastic collision between two objects in which mass of one object is very much greater than the other. See, guys, this case is important. This case is important. I want you to understand this very carefully. I want you to understand this very carefully. What is that? See, guys, elastic collision between two objects in which mass of one object is very much greater than other. See, guys, here you have elastic collision between two objects. Like if let's suppose there is a truck. This truck is moving with some velocity that is u1. Okay. It strikes the B. This is the B. Okay. Mass of the B is m and it is moving with velocity u2. B. In Hindi we call it cheety. Okay. Mass of the truck is large. When truck strikes the B, okay, when truck strikes the B, what is going to happen with the velocity of truck? Nothing. Okay. Now, what is the velocity of B in this particular case? If the smaller mass moves, so case 1, if the smaller mass moves in the same direction, means, this is the truck and it strikes the B. This truck is moving in the forward direction. B is also moving in the forward direction. When truck strikes the B, so this moving with velocity u1, this will move with velocity v2. This is v1, this is v2. Can I say in this particular case, my dear NEET aspirants, listen to me very carefully. What I can say, we say velocity of the truck. I'll just write over here. velocity of truck, it is going to be V1 will be equals to U. Velocity of the truck will be V1 is equal to U. Okay. Okay. Yes. Velocity of the truck is V1 is equal to U1. Because nothing is going to happen with the velocity of the truck because mass is extremely large. And if I say velocity of B, okay, simply you will be directly remembering V2 will be equals to 2 times of U1 minus U2. 2 times of U1. U1 is the velocity of truck. U2 is the velocity of B, initial velocities. This is what you guys need to remember. This is what you guys need to remember afterwards. This is after the collision. After the collision. Now, second case in this one is, see guys, case 2. If the smaller mass moves in the opposite direction, now see, this is the truck. It is moving with velocity u1 in the forward direction. And there is this B. It is moving with u2 in the opposite direction before collision. When the collision takes place. So truck will move with the same velocity in the forward direction. Nothing is going to happen with the truck. And this B, it will change its velocity direction. It will start moving in the forward direction. Okay. In this particular case, if somebody says, what is the velocity of truck? Velocity of truck. Velocity of truck. After the collision, V1, that will be equals to U1. Nothing will happen to this. Okay. Nothing will happen to this. And if I say, what is the velocity of B in this particular case? So V2 will be equals to velocity of B. V2 will be equals to 2 times of U1 minus U2. That is what we have studied recently. Same formula here also. But I can write this V2 will be 2 times of U1 minus. What is the value of U2? Sir, U2 is over here negative. Why? Because it is moving in the backward direction. Okay. Minus, I would say U2. And in this particular case, what I can say, minus U2 will be minus U2. Something like this. So V2 will be 2 times of U1 plus, I would say, U2. So this is the velocity of the B when the B is moving in the opposite direction. Okay. Now there is this question. So before this question, let's take a break. Break is for 15 minutes. Okay. Let's take a break of 15 minutes. So I'll be back after the break. Okay. Hello, check, check. Yes, it is working now. Just yes. Now, guys, let me quickly revise this. A heavy vehicle moving with a velocity of 15 meter per second strikes an object of very small mass at rest head on elastically with a velocity then the velocity of the second object is. See, guys, it says that you have a truck. It is moving with a velocity of 15 meter per second. There is a small mass. Its velocity is zero. It's at rest. Now it says what is the velocity of this small mass after the collision. So V2 is 2 times of U1 minus U2. This is the formula we studied. V2 is equal to 2 times of U1 because U2 is 0. Small mass is at rest initially. So U1 is 15. 2 into 15 is 30. Then, my dear friends, fraction of kinetic energy transferred in case of elastic collision. See, guys. You have a mass M, okay? It is moving with initial velocity U. It will have some kinetic energy, 1 by 2 m U1 square. There is another mass, it is n times of m. N can be anything. So its initial velocity is 0, it's at rest. So when this mass strikes with this, now the second mass will now start moving also with velocity U, V2. This mass is having the velocity V1 now. So don't you think that initially only this mass has kinetic energy? When it strikes with this mass, now it has transferred some portion of the kinetic energy to this. So how much is the kinetic energy transferred to the second object? Fraction of kinetic energy transferred to the second object. Directly you'll be remembering that is 4n upon 1 plus n square. This is the kinetic energy transferred to the second object. And how much is the kinetic energy retained in the first object? That is 1 minus n upon 1 plus n whole square. As simple as that. If I say I have 10 rupees, I am giving 5 rupees to somebody else. How much is the energy how much is the money transferred? 5. How much is retained? 5. Similar question is NEET 2019. There is a 4 kg mass and there is 2 kg mass. It is basically colliding with this 2 kg mass. Okay, colliding with 2 kg mass, which was at rest. In this particular case, how much is the energy transferred to the 2 kg mass? So kinetic energy transferred will be 4n upon 1 plus n whole square. Now n will be how much? Guys, n is always bigger mass divided by smaller mass. 4 divided by 2. That is 2. So 4 into n upon 1 plus n whole square. So 4 into 2 upon 1 plus 2 whole square. So this will be 8 divided by 9. 8 by 9. Then a proton is moving with a velocity of u, collides with the nucleus of mass number A. So basically there is a proton. In this question it says, you can read the question. And in this question it says there is a proton. It is moving with velocity u. It strikes with the nucleus. Nucleus has mass number A. Mass number means how many number of particles are inside the nucleus. If 10 particles, A is 10. If 20 particles, A is 20. How do we find the mass of nucleus? Mass of nucleus is mass number multiplied by mass of nucleons. So mass of nucleon means M. Mass of one nucleon is M. Mass number is A. So A into M we write. If let's suppose nucleus has 15 mass number, so 15 M is the mass, total mass of the nucleus. So this is A into M. So when this strikes, how much is the kinetic energy retained in this one? So retained kinetic energy will be simply 1 minus n upon 1 plus n whole square. Okay. Kinetic energy retained. Like this is the kinetic energy transferred. This is the kinetic energy retained. 1 minus n upon 1 plus n whole square. Okay. So here kinetic energy retained will be 1 minus n upon 1 plus n whole square. 1 minus, what is the value of n? N will be bigger mass, A into M upon smaller mass, that is M. M and M will be cancelled, so it is A. So 1 minus A upon 1 plus A whole square. You can write it like this. A minus 1 upon A plus 1 whole square. Okay. Then I was telling you, elastic collision between two objects having same mass. If you have two objects with same mass and collision is elastic, they will interchange the velocity. If it is, this is moving with 10, this is moving with 20. If they collide, now after the collision, this will have 10, this, if this is having 10, this is having 20. After the collision, this will have 20, this will have 10. Velocity is interchanged. Then, next question I told you, find the maximum height attained by the bob from the mean position if the collision is elastic. See, there is a mass attached to the string. There is this mass which is moving with velocity v naught. If this strikes with this bob, this mass, so this will come to rest and this will go up with velocity v naught because velocity is interchanged and it will reach here. How much is the height attained? This height will be v naught square by 2g. Okay. In the same question, I told you this. Find the maximum height attained by the bob from the mean position if the collision is elastic and masses are different. If the two masses are different, this is m and this is small m. This is moving with velocity v naught. Collision is elastic. Sir, we say when this strikes this, it will go up and reach here. How much is the height? Height is again the same. The velocity here divided by 2g. It's velocity square by 2g. Now you need to find this v2. Sir, how can we find v2? If the collision is elastic, how to find the velocity after the collision? Use this formula. v2 is equal to m2 minus m1 into u2 upon m1 plus m2 plus 2 times of m1 upon m1 plus m2 into u. This will be 0. Why? Because initial velocity of the second mass is 0. So u2 is 0. This term will become 0. So v2 will be 2 times of m into v naught divided by capital M plus small m. 2 times of m1 is capital M. u1 is v naught. Okay. u1 is v naught. Then m plus small m. This is v2. So now this will be the height. Height is this. So what can you write in this particular case? So this h is going to be, that is v2. Instead of v2, you'll be writing 2m v naught. So that is going to be 2m v naught divided by m plus small m. m plus small m, its whole square, and then 1 by 2g. So what can you write? 2 square is 4, m square v naught. Then upon, and this is capital M, not the small m. Sorry. M, this is m, divided by m plus small m. That is 2g. I would say m square, or you can write it like this, m plus small m whole square. This is going to be the height in this particular case. I hope this is clear. So if the two masses are same, then the velocity is directly transferred. If the two masses are not same, in that particular case, you will have to find the velocity if the collision is elastic. The collision is elastic. I believe this is clear. Then guys, this is also an important topic which I would like to tell you over here. This is also an important topic which I would like to tell you over here. See, what is the topic? What is the topic here? Take a look. There is an object of mass m. Okay. First write the topic. Velocity and height after n collisions. Velocity and height after n collisions. Okay. Absolutely. Take a look. Take a look. You have an object. Okay. and it is dropped. You have dropped the object from certain height. Initial velocity is 0. Whenever you release an object, its initial velocity is 0. Okay. Now, my dear NEET aspirants, it will fall by a height of h. Now, this is the velocity with which it strikes the ground. Velocity before collision. This is the velocity with which it strikes the ground. And then it will be reflected again. This is the velocity after collision. This is the velocity after collision. And this is the height covered before collision. This is the height covered after the collision. HAC, height covered after the collision. Absolutely, sir. First and the foremost thing I want you guys to understand in this one, listen carefully, listen carefully. Take a look, take a look, take a look. If my dear NEET aspirants, if I say the velocity with which it strikes the ground, if an object is released from certain height, okay, if an object is released from certain height, so with what velocity it is going to strike the ground? This. Okay, we say the velocity with which it strikes the ground. The velocity with which it strikes the ground. So, my dear NEET aspirants, when it comes to the velocity with which it strikes the ground, listen carefully. That is UBC. If an object is released from certain height, with what velocity it strikes the ground? Under root of 2gh. This we have studied already. Already we have studied. Now tell me. We can say as we know. What do we know? What is the coefficient of restitution? Coefficient of restitution is velocity of separation, okay, divided by velocity of approach. We have studied this. What is the velocity of separation? Guys, see, with what velocity they are colliding, that is the velocity of approach. With what velocity they are separating. After the collision, it is velocity of separation. Before the collision, velocity of approach. So I can write over here, velocity of separation is velocity after collision. Velocity of approach is velocity before collision. That is UBC. So here you can say velocity after the collision is going to be E times of velocity before the collision. Absolutely, sir. This is the first equation that you will be remembering over here. This is the first equation that you will be remembering over here. Yes, sir. Yes, sir. Then, my dear NEET aspirants, if I say, can you write it like this also? Velocity after the collision is equal to E times of, what is velocity before the collision? UBC. Recently you got that, under root of 2gh. I can say under root of 2g into h. You can write it like this also, where h is the height before collision. Where h is the height before collision. Where h is the height before collision. Absolutely, sir. Now, my dear NEET aspirants, what is the height covered after the collision? Listen to me very carefully. Height covered after the collision. What is the height covered after the collision? Guys, this is the velocity after the collision. If an object is thrown with some velocity, how much height it is going to cover? How much height it is going to cover? U square by 2g. In vertical motion we have studied. So height covered after the collision, it is going to be U square, initial velocity, with what velocity? That is velocity after the collision square divided by 2g. What is velocity after the collision? This. So you'll be like velocity after the collision. That is E, its square. Will be E square 2gh divided by 2g. So what can you cancel here? 2g and 2g. So height. So I can write over here height after the collision is equal to 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 that is E square into h. E square into h. E square into h. This is the height after the collision. This is the height after the collision. Absolutely, sir. Now, my dear NEET aspirants, what I'm trying to say over here is that this is the height after the collision. Okay, E square into h. And what is this h? H is the height before collision. So you can, it is better to write it like this. It is better to write it like this, height before collision. So from here you can say E square is equal to height after collision upon height before collision. From this, keep this in a box, and you can say E square, and E will be actually under root of height after collision upon height before collision. In some questions you'll be using this particular formula. You'll be using this particular formula in certain questions. Okay. Okay. Absolutely. Now guys, take a look. If I say, what is the velocity after second collision? What is the velocity after first collision, guys? Velocity after first collision is this. E raised power 1 UBC. And if I say, what is the velocity after second collision? After second collision. You'll be simply saying, sir, velocity after second collision, that is going to be E raised power 2 UBC. And if I say velocity after nth collision, nth collision, let's suppose it is doing n collisions with the ground. So velocity after nth collision, it is going to be E raised power n UBC. That is velocity before collision. So n can be anything. If somebody says, what is the velocity after fifth collision? Put the value of n is equal to 5. That's it. Put the value of n is equal to 5. You'll get the correct answer. And my dear NEET aspirants, similarly, when it comes to height after nth collision, height after nth collision. Okay. Guys, see, if you check over here, height after first collision, E raised power 2 HBC. Height after nth collision, if I just write over here, I'll write E raised power 2n, height before collision. Yes. Everything is sorted. Now, if you put n is equal to 1, put n is equal to 1, what will you get height after first collision? That will be E raised power 2 HBC. Yes, that we already proved. So, my dear NEET aspirants, in this particular problem pattern, if an object is released, it strikes the ground, then it goes, okay, this is the velocity before collision, this is the velocity after collision. This is the height covered after collision. Okay, then it falls down. This is the height velocity after second collision, and this will be the height after second collision. Similarly, it can do n collisions. I have told you the complete detail over here. You can check it. You can understand this also. Now, see, there is an important question pattern which I would like you to, which I would want you guys to directly remember. Which I would want you guys to directly remember. See, what is the question pattern over here? A body of mass m falls from a height h. There is a body of mass m which falls from a height h. Okay, on the ground, which falls from a height h on the ground. There is a body of mass m which falls from a height h on the ground. Okay, if E be the coefficient of restitution, if E be the coefficient of restitution between the body and the ground, then the distance traveled by the body before it comes to rest. See, guys, let's suppose this body falls, it covers height h. Then again it goes. This is the height after first collision. How much is E square into h? I have told you e raised power 2n into h, height before collision. So e raised power 2 into n is 1. So height before collision is h. So e raised power 2h, this height. If this height is e raised power 2h, this height will be also e raised power 2h. This height will be e raised power. Okay, then height after second collision. What is height after second collision? H is equal to e raised power 2 into n. N is 2. Height before collision is height after second collision. So e raised power 4h. That's what I'm saying. This will be e raised power 4h, e raised power 4h. Similarly, this height after third collision, height after third collision. If I say this body again goes up, and here it comes to rest. So you have to calculate the distance covered. This distance plus this, plus this, plus this, plus this, plus this, plus this, all these distances. So my dear NEET aspirants, if you add all these distances, listen carefully. And I would say directly remember this expression. There will be GP series expression will be there. It will form a GP series. You don't have to solve it. How much is that? Basically, you're adding these height, this plus this plus this plus this plus, and so on. But I want you to directly remember this. This is the total height or total distance covered after n collisions. So h 1 plus e raised e square upon 1 minus e square. And if somebody says how much is the total time taken, sir, time taken in this, time taken in this, time taken in this, time taken in this, time taken, total time taken when it comes to rest. So this is the total time. Under root of 2h divided by g, 1 plus e upon 1 minus e. This is the total time taken. I hope this is crystalline clear. I hope this is crystalline clear. Okay. You can directly remember these two expressions. No need to derive this. You will get the proper answer. You will get the proper answer. Okay. Yes. Now, fraction of velocity lost after the collision. Fraction of velocity lost after the collision. Okay. Yes. See, guys. See, guys. See, guys. See, guys. Let's take a look. Let's take a look. When this body is thrown with velocity u and u is constant, it strikes the ground. So when it strikes the ground, after the collision, my dear NEET aspirants, it will have different velocity. So some velocity is lost. I'll mention over here. If the body collides with the ground after the collision, velocity, we say if the body strikes the ground, if the body strikes the ground, some velocity is lost. Okay. Okay. Now, my dear NEET aspirants, we can say as velocity coefficient of restitution is velocity of separation. That is velocity after the collision, velocity before the collision. This we have studied. So velocity after the collision is equal to velocity before the collision. What is the velocity before the collision? Here also velocity will be u because u is constant. So that is u into e. Now, if I say, my dear NEET aspirants, what is going to be the change in velocity in this particular case? Guys, see, change in velocity. Change in velocity will be velocity after the collision minus velocity before the collision. So that is going to be e into u minus u. U will be taken out, e minus 1. Okay, change in velocity. Now, this change in velocity also we can call it the loss in velocity. This is the loss in velocity. Now, if I say fractional loss in velocity, understand this very carefully, guys. If I say fractional loss in velocity, fractional loss in velocity. So this is also considered as loss in velocity. If I say fractional loss in velocity, my dear NEET aspirants, take a look when we define fractional loss in velocity. When we define fractional loss in velocity. Fractional loss in velocity simply means that is change in velocity, delta v divided by original velocity, that is u into e minus 1 upon u. U and u will be cancelled, so it is e minus 1. So if somebody says what fraction of velocity is lost when it strikes the ground, so that is e minus 1. So fractional loss in velocity, it is e minus 1. No need to derive this, my dear NEET aspirants. You can directly remember it. So what I want you guys to understand, if an object is released with velocity u is constant, and it strikes the ground, when it strikes the ground, afterwards it is reflected back. When it strikes the ground, afterwards it's reflected back. So my dear NEET aspirants, when it is reflected back, so it is reflected with the same velocity, that is e minus 1. Sorry, it is reflected back. So it is reflected back, so means velocity is lost in this case. So what is the fractional loss in velocity? That is going to be e minus 1. This is the fractional loss in velocity. I believe this is crystal and clear to each and every single student. This is the fractional loss in velocity. Okay? This is the fractional loss in velocity. Now, guys, there is a case 2 also over here. If a body is released from certain height, okay? Release means initial velocity is 0. Here, initial velocity is not constant. Here, initial velocity is 0 from certain height h. Okay? Now, my dear NEET aspirants, what I can say in this particular case is, if a body is released from certain height, what is the velocity after n collision? That is okay. Here. Okay. This we know what is the velocity after n collisions. Velocity after n collisions, this is already we have studied. Na? What is the velocity of the body after n collisions? E raised power n into u. Okay. After second collision, you will be putting e raised power 2 into u. So e raised power n u means what is the velocity with which it strikes the ground? That is under root of 2gh. This is, we know, this we know. Okay, 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 okay. I hope these two expressions are also clear. Huh? These two expressions. We don't have to derive these two expressions. You can directly remember it. You can directly remember this also. Now, boys and girls, let's take a look at this particular question. See, a ball is allowed to fall. A ball is allowed to fall from a height of 10 meters. A ball is allowed to fall from a height of 10 meters. Okay. A ball is allowed to fall from a height of 10 meters. Understand this very carefully. Okay. Okay. A ball is allowed to fall from a height of 10 meters. Okay. And the loss in the energy is 40%. See guys, the question. We have a ball over here. We have a ball over here. And it is mg into h. At topmost, it is at height h. So what is the potential energy of the ball? Mg into h. It is allowed to fall from a height of h is equal to 10 meters. Okay. Then it says the loss in the energy is 40%. In this case, energy loss is 40%. Okay. Absolutely, sir. Energy loss is 40% due to the impact. Okay. A ball is allowed to fall from a height of h is equal to 10 meters. Okay. 10 meters. Loss in the energy is 40% due to the impact. After one impact, the ball will go up by. After one impact, the ball will go up by. We have to find out energy loss in this particular case is 40%. After one impact, the ball will go up by how much? How much? Okay. So this is the height we have to cover. Find out. Okay. Yes, 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 yes. Now, my dear NEET aspirants, what will I say in this particular case? Listen to me very carefully. So basically, when this ball strikes the ground, it will be reflected back. It will go up by a height of h. We have to find out after one impact how high it can go. After one impact, how high it can go. Listen carefully. We say energy after the collision till it goes height h. Energy after the collision, if it goes till height h. Energy after the collision till it goes height h. Guys, what is the energy of this? What is the energy of this? What is the energy of this? At this particular instant, you'll be simply saying, sir, energy of this will be here, remaining energy. That is, guys, if it has lost 40% of the energy, how much is the remaining energy? 60%. So at this height, how much will be the energy? 60%. So I can say this is going to be 60% of mg into h. This height, this is h. Keep this at capital H. Okay. And what is the energy at this point? What is the energy at this point? That is mgh, small h. So value of mg into small h is 60% of mg into capital H. M and M will cancel, G and G will cancel. So this height will be 60% of h. So 60 means 60 divided by 100. 60% means 60 by 100 into h. 0 and 0, 6 by 10. Okay. Okay. So 6 by 10 into h. So h is equal to 6h divided by 10. Now what is the value of h? H is 10. So 6 divided by 10 into 10. 10 and this will cancel. So 6 meters. 6 meters. Okay. A rubber ball is dropped from a height of 5 meters. A ball is dropped from a height of 5 meters. Okay. H is equal to 5. Then it says, on a plane where acceleration due to gravity is not known. Okay. G is unknown. On bouncing, it rises to 1.8 meters. On bouncing, it rises to 1.8 meters. This height is 1.8 meters. Okay. The ball loses its velocity on becoming by a factor of, on bouncing. The ball loses its velocity on bouncing by a factor of. We have to find the fractional loss in kinetic energy, fractional loss in velocity. Fractional loss in velocity. Okay, that is going to be E minus 1. Fractional loss in velocity is how much? E minus 1. Okay. And guys, we don't know the value of E in this particular case. E we can find out with this. Height after the collision, height before collision. Here, I have explained it. What is the value of E? This expression. Same expression I'm using here. E is equal to height after the collision, height before collision. So you can write it. Height after the collision is 1.8. Height before the collision is 5. See? 1.8 and 5. Now what can I write in this particular case? So this is going to be under root of 18 divided by 10. 10 into 5 is 50. So 1.8 by 5, we can write 18 by 50. So 2 9s are 18, 2 25s are. So root 9 by 25. So that is 3 divided by 5. Okay. This is the fractional loss in the velocity. Sorry, this is the value of E. So fractional loss in velocity. Fractional loss in velocity. That is going to be E minus 1. So 3 by 5 minus 1. That will be minus 2 by 5, or we say 2 by 5. Okay. So we are done with the collisions. Done with the collisions. Okay, my dear NEET aspirants, we are done with the collisions. Okay, so that's all for today, guys. See you. Take care and bye-bye. Thank you so much.